Hello everyone, how are you doing today? What this first video is going to be on is examples 1 through 4. Then I'm going to make a video on 5 through 6. 5 through 6 are on summations. Those are fairly new to you and they are necessary in calc. This first section, many of you guys are going to remember how to do it, and then if you get part way through it and say I know how to do it, you can skip this first video. The second video, I need each and every one of you to take notes on it no matter what. Please do not cheat yourself on it. If you guys are going into calc or if you're doing anything that has any math that's involved in it, calc is super important and a steady base is very, very important for you. So the first thing we're going to do is just talk about what a sequence is. The definition of a sequence: an infinite sequence, as you know, is going to be a sequence that goes on forever all the way to n terms. You start out with a sub 1, a sub 2, a sub 3, a sub 4, all the way to a sub n. Okay, sequences whose domain consist of the first n positive integers are called a finite sequence. Okay, a finite sequence has a set number, okay, and then a infinite sequence, as you know, has n numbers in it. Okay, and that's the way I kind of like to think about it. So the first couple things we're going to do is something that you guys have already kind of seen in Algebra 1 and Algebra 2. Write the first 4 terms. What this means is we are going to substitute in 1, 2, 3, and 4, and then we're going to find our terms based off of that. So the first one, a sub n, a sub 1 means we're plugging in 1. So we have 3 times 1 plus 4, so that's 3 plus 4, which is 7. A sub 2 is going to be 3 times 2 plus 4, which is going to be 6 plus 4, which is 10. A sub 3, when you plug this in, you're going to have 3 times 3 plus 4, which is going to be 9 plus 4, which is 13. If you guys start to notice a pattern between each of these, we're just adding 3 to it. Specifically, we have 3n. That means we're going to add 3 each time. So we're going to get 16 for this, okay? The same sort of pattern follows, but in this next one, it might not be as simple as just adding 3 each and every time. With this, when we're taking a look at it, let me go ahead and do it in pink. We're doing the same thing. We're plugging in 1. So we have negative 1 to the power of 1 over 3 to the power of 1 minus 1, which means we're going to have negative 1, and then we're going to have 3 minus 1, which is 2. So we have negative 1/2. Then we go to the next one, a sub 2, we're going to have negative 1 squared, which is now going to give us a positive 1 on top. And then 3 squared minus 1 is going to give us 8, so we have 1/8. Let's see if we can find a pattern in this third one. So we're going to have negative 1 to the power of 3, which means we're going to have negative 1 on top. And then 3 cubed minus 1, which is 27 minus 1, which is 26. So is there anything that we can multiply to get from 2 to 8 and then from 8 to 6? Is there a set pattern here that we can find that doesn't change as easily as that? So we'd multiply by 4. Then if we multiply by 4, that's not giving us the same value. And that's because we have this to the power of n and we have this minus 1. There is a way to find that pattern. If you guys would like to see and figure that out on your own, go for it. And then a to the power, or a sub 4 is going to be negative 1 to the power of 4, which every time you have an even number, it's going to give us a positive on this. And then 3 to the power of 4 minus 1. So 27 times 3 is 81. 81 minus 1 is 80. So that's our first one. Okay, guys, please, if you need to, go ahead and press pause at this point and do checkpoint 1 for me. Okay, we're going to go on to example 2. Example 2 is using the recursion method, which means you're given your first term and you have to plug it in to this. And then once you find that you have your second term, then you plug your second term in for this once again. And then you guys are going to be able to find your first 4 terms doing that. What this n is greater than 2 means is that we're going to plug in, this is already our first term, so we're going to start at term 2. So we're going to have 5 already as our first term, and then we're going to go through and find the rest of them. Okay, so from that, what we're going to do is we're going to go ahead and plug in a sub 1. So we're going to have a sub 2 equals 3 times 5 plus 2, which is 15 plus 2, which means we're going to get 17. Okay, And then what we're going to do is take 17 and plug it in. And when we do that, we're going to find our next term. So when we do that, we're going to get a sub 3 equals 3 times 17 plus 2, which is going to give us 3, 30, 21, 51 plus 2, I believe. Maybe wrong. I don't think I am, but I may be. And we're going to get 53 from there. Okay? And you go about it the same exact way until you find your next terms, which are going to be 5, 17, 53, 161, and that'll be the first 4 terms. So a sub 4 will give you 161. 3 times 53 plus 2 is going to be 161. Okay, at this point, go ahead and hit pause, and I'd like you guys to please try checkpoint 2. All right, let's go on to the next one. This next one's going to be using factorials, which we've seen some in Algebra 2, but we haven't seen a ton of it. Through this, what we're going to be doing is we're going to be reading just through it in a minute, and then we're going to see where it goes from there. A factorial, something written as n factorial, is going to give us something written this way, and whenever I see it like this, if I were a student, I'd be like, what the heck does that mean? Essentially, if I give you something like 3 factorial, that means 3 times 3 minus 1, which is 2, times 3 minus 2, which is 1, and then we're done. So this is going to give us 6. Okay, if I give you 5 factorial, that means we're going to have 5 times 4 times 3 times 2 times 1. And when I do that, this is going to be 20, and this is going to be 6. So 20 times 6 is 120. Okay, and it works the same way for anything that's given a factorial. And what we're going to be doing is using factorials when we are going about this. Why is that? Because when we get to summations, factorials, you will be seeing them on and off, okay? You will see them some in calc as well. So I just want you guys to get used to seeing that. So here's example 3. What we're supposed to do is find the first 4 terms. So we're going to be plugging in 1, 2, 3, and 4. And essentially, we're going to have a sub 1 equals 2 to the power of 1 over 1 minus 1 factorial. Okay. Now, if you guys recall, when you have 0 factorial from Algebra 2, we found this by making a table and working our way backwards. And we're able to find that this is actually going to give us 1. So we get 2. Okay. So once again, 0 factorial is equal to 1. Okay. Once we go from there, we're going to be plugging into a sub 2 is going to be 2 to the power of 2 all over 2 minus 1 factorial, which if we do this, we're going to get 1 factorial, which is still just 1. Okay. Then we just continue to go from here, and we're going to find our next values. I just wrote 2 squared is equal to 2. I'm sorry for that. It is equal to 4. Okay. That one is on me. Then we're going to find a sub 3, where we get 2 to the power of 3 over 3 minus 1 factorial. And this is going to give us 8 over 2 factorial, which is 8 over 2 times 1, which is just 8 divided by 2. So we get 4. Okay, and as we keep going, we're going to start seeing some patterns. The factorial is going to overtake our exponential in this case. And an interesting question to think about is what grows faster, a factorial or an exponential? What case would an exponential have to have for it to grow faster than a factorial? Is that ever the case? For what values would that work for? So then we're going to have 2 to the power of 4 over 4 minus 1 factorial, which we're going to get 2 to the power of 4 is 16 all over 3 factorial. And we just found that 3 factorial is 3 times 2, which is 6. And then we just reduce this, and we're going to get 8 over 3, 8/3. Okay, so that's all for example 3. I'm going to give you guys a moment. Please go ahead and try out checkpoint 4 for me, please. All right, now we're going to go on to our last one. This is where we're going to be evaluating factorials with fractions. You guys are going to see some patterns as you go through it. And I'm going to walk you guys through some patterns on this first one. The second one's a little bit more interesting by my book, but the way you look at it is 10 factorial is essentially 10 times 9 times 8 all the way to 1. 2 factorial is 2 times 1. 8 factorial is 8 all the way to 1. So if you guys know anything about multiplication, we're able to just switch things around. We're also able to, in this case, we're able to divide through by some numbers very, very easily. And if you guys are looking at it, we have this entire block in common. So what can we do with that entire block? Well, if we're dividing, can't we just cancel those out? And we're left with 10 times 9 over 2. So this is going to give us 5 times 9, which is going to be 45. That actually worked out very nicely. Okay. This next problem, once again I said this is just a little bit more interesting because now we're working with different values. We're working with all values of n. So in this case, this top one is going to be n plus 1 factorial, which is going to be n plus 1 times, if we take away 1 from it, we're going to have n. If we take away 1 from it, we're going to have n minus 1. Then we're going to have n minus 2 all the way. Okay. And then if we do the same thing with n factorial, we're going to have n, and then n minus 1, and then n minus 2, all the way. So if you guys are looking at this, what do these have in common? So if we're thinking about it this way, we're going to go ahead and find that we have this entire block all the way out towards infinity. We have that in common on top and bottom, so we're actually able to go through and cancel those out, and we're left with n plus 1. Okay, I think this is super interesting because we have this n plus 1 left over. If we had a full class, I would actually go through and we'd be going through all of these rules all over again because I love it. What I'd like you guys to do is please go ahead and you guys can go ahead and start on the next set of videos. Thank you very much. I'm going to start the next one.